let's take a look at the answers for exam 1Y. The length in millimeters of the mesiodistal crown of the first molar for human fetuses can be approximated by L of t is equal to negative 0.01 t squared plus 0.788 t minus 7.048, where t is the number of weeks since conception. Question A. What is the length of the mesiodistal crown after 28 weeks? So here we need to find L of 28. So we'll plug in 28. And we get 7.18 millimeters. Question B. When will the length of the mesiodistal crown be 5 millimeters? So take the equation, set it equal to 5. Now we have a quadratic, so we need to move the 5 to the left. So everything stays the same except the constant term. And once it's equal to 0, then we're going to use the quadratic formula to solve this problem. Alright, and there's the quadratic formula for solving this problem. We get two answers. We get t is equal to 20.76 weeks, and we get t is equal to 58.04 weeks. We'll learn in the next part of the question, that this second answer is invalid. So we'll just get rid of it now. Question C, what is the maximum mesiodistal crown, and when does this maximum occur? So since we have a quadratic, the maximum occurs at negative b over 2a. So that's negative 0.788 divided by 2 times negative 0.01, which is 39.4 weeks. And so then that maximum length of the tooth crown is 8.48 millimeters. And the bonus question was, explain why the maximum occurs at this time. It's because human gestation is about 40 weeks long, and so after that, the baby comes out. Alright, let's take a look at question 2. The population of gray wolves in Montana can be modeled by the function w of x is equal to 430 e to the 0.11 x power, where x is the number of years since 2007. How many gray wolves were there in 2010? Well, 2010 is 3 years since our base year of 2007. So we need w of 3, which would be 430 e to the 0.11 times 3. And if you work that out, you get 598 wolves. Question B, assuming the wolf population continues to grow based on the model, in what year can we expect the population of gray wolves to exceed 10,750? So we'll go ahead and set 10,750 equal to the gray wolf population equation. The first thing we need to do when we solve this is divide by that leading coefficient there, that 430. That gives me 25 is equal to e, oops, this is not x, this should be x right there. This gives me 25 is equal to e to the 0.11x. And now whenever we go to solve, when x is in the exponent, we take the natural log of both sides. That gives me the natural log. Let's look at the answers for quiz 1y. Here we have a graph, and part A says find the limit as x goes to 2 from the left. So I'm going to trace over the graph here, and as we get closer to x equals 2 from the left, we see that the y value goes to 1. over 0.11.
Part B, find the limit as x goes to 2 from the right.
29.26. Now we're looking
trace
for
from the right
actual
side as
year.
x goes
So
to
we'll add that to the
2
base year
from the right side. We see that we get
2007.
down to -4.
And that's the year.
Part C, find the limit as x goes to 2, the full two-sided limit. Since the two one-sided limits are not the same,
that year,
the full limit does not exist.
Itself.
Next, find the value of f of 2. That's where the function is defined.
So the limit is
you
x
look
goes
for the
to
solid
2 from
dot
the right,
where the function would be defined,
-4.
and that is at 1.
The limit is x goes to 2 from the left.
And part E is
2.
f continuous at x equals
whole
2.
limit
The answer is no,
because
and that's because the limit as x goes to 2 of f of x
is where the solid
does
dot
not
is,
exist.
which is -4. And is the function continuous at 2? The answer is no.
Question 2. Suppose x goes to 5, the limit as x goes to 5 of f of x is equal to 7, and the function value f of 5 is equal to 9.
So the top factors
what can you say about the limit as x goes to 5 from the right? And what can you say about the limit as x goes to 5 from the left?
X minus
well,
12
since you have that the limit exists and is equal to 7, you know that both one-sided limits have to have that same value as well. If either of the one-sided limits was different than the other, then the limit would not exist.
So it's 12.
Notice that the fact that f of 5 is equal to 9 does not play a part in this question. Simply knowing that the function value at 5 is 9 is irrelevant. In fact, the graph may look something like this. X is going to 5,
factor out the top.
The limit is going to 7, it may look something like that, and the function value itself is 9. So there's a solid dot at 5, 9, but there's certainly an open circle, a hole at 5, 7.
That leaves me with the limit as x goes to -3.
Let's look at problem 3. Find the limit if it exists. So if you were to plug in x equals 7,
and so that gives me -3 squared over -3.
This one may actually
10,
work. Let's see.
Which is 9 over 7.
Seven squared plus 3 times 7 minus 28.
Question 5. Find the limit. So here we're taking x as it goes
0
to infinity.
Over
so we will
49
divide each
plus
term
21
by the
minus 28.
Power of x from the denominator.
The bottom is not going to be 0. It's going to be
in this
42.
Case, that is just
so 0
x
divided by 42 is 42.
Next, we simplify.
So this one you did not need to factor and cancel. It was going to work anyway.
And now as we take the limit as x
Problem
goes
4,
to infinity,
find the intervals where the function g of x is equal to the square root of 15 minus 4x is continuous.
So this is 11.
So recall from our notes that a square root function is continuous everywhere that the inside function is greater than or equal to 0. So we'll set 15 minus 4x greater than or equal to 0.
The highest power of x in this problem from the denominator
move the 15
is
to the
still
right
x
side.
to the first.
We now have minus 4x is greater than or equal to -15.
Except that the terms in
divide
the numerator
both sides
are
by -4.
So as the
and recall from algebra that when you divide an inequality by a negative, you need to switch
squared.
the inequality. So the function is continuous on -infinity to 15 over 4, closed at 15 over 4.
Simplify. Now, any term that still has x on the bottom goes to 0. So this is going to be 49 plus 0 plus 0 divided by 9 plus 0, which is the square root of 49 over 9, which is 7 over 9. Question 6, find the intervals where each function is continuous. Well, the first function is rational, so we'll take the denominator and set it equal to 0 and solve. So we get x equals 13. So this function will be continuous from negative infinity to 13, union 13 to infinity. Question B, the function g of x is the natural log of 7x minus 17. Natural log functions are continuous everywhere that their arguments are greater than 0. So just set the inside greater than 0 and solve. We get 17 over 7. So this is 17 over 7 to infinity. Question 7. Use the limit definition of derivative to compute this derivative. So this would be f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Let me go ahead and evaluate the function at x plus h. So that would be x plus h squared plus 5 times x plus h plus 17 minus the function itself, x squared plus 5x plus 17 over h. In the next step, I'm going to multiply out x plus h squared. So that's x squared plus 2hx plus h squared. Distribute the 5, so it's 5x plus 5h plus 17 minus x squared minus 5x minus 17 over h. Now we cancel, and we can cancel the x squares, the 5x's, and the 17's. And that leaves us with 2hx plus h squared plus 5h over h. That's the limit as h goes to 0 of h times 2x plus h plus 5 divided by h. The h's cancel. And we have the limit as h goes to 0 of 2x plus h plus 5. Evaluating the limit, h goes to 0. So we get 2x plus 0 plus 5, which is 2x plus 5. Question 9. The total amount of snow in inches that has fallen in a city is given by s of x is equal to 10x minus x squared for x between 0 and 5, where x is the number of hours since midnight. Find the average rate of change in the amount of snowfall between 2 a.m. and 5 a.m. So since midnight, 2 a.m. is 2 hours, and 5 a.m. is 5 hours. So we're looking for average rate of change between 2 and 5. So this is s of 5 minus s of 2 over 5 minus 2. Evaluating those functions, you get 25 minus 16 over 3, which is 9 over 3, which is 3. And now we need the appropriate unit. S is measured in inches, and x is measured in hours. So it's 3 inches per hour. Question B, at what rate is the snow falling at 1:30 a.m.? 1:30 a.m. is 1.5 hours since midnight. To find the rate, we need the derivative. So s prime of x is 10 minus 2x, and then we're going to evaluate the derivative at 1.5. And so it would be 10 minus 2 times 1.5, which is 7. And again, it's inches per hour. Question 9, find each derivative. So f prime of x is equal to 54x to the 8th minus 21x to the 6th plus 8. Question G, we want this derivative, but we need to simplify it first into a form that we can take the derivative of. So we have x raised to the 11 over 6 minus 7 times x to the negative fifth. Now g prime of x is 11 over 6 x to the 5/6 power plus 35x to the negative 6. And then we want to revert this back to the form that it started with. So it's 11 over 6 times the 6th root of x to the 5th plus 35 over x to the 6th. And finally, let's take a look at question 10. Match each function on the left with its derivative on the right. So it was c, a, d, e, and b. All right, thanks for watching.